I'm a little gassy.
Hello, and today we're going to talk about the simple gas laws. The gas laws date back to the 18th century, and the simple gas laws deal with how a gas will behave in respect to its pressure, temperature, and volume. The pressure can be measured in many different units, including, but not limited to, atmospheres, kilopascals, and millimeters of mercury. The volume that gas occupies can be measured in liters or milliliters. When using the gas law equations, the temperature must be in Kelvin.
The first gas law is Boyle's law. Boyle's law deals with the relationship between the pressure and the volume of a gas. They have an inversely proportional relationship, which means while one goes up, the other goes down. As an equation, this looks like pressure 1 times volume 1 equals pressure 2 times volume 2, where P is the pressure and V is the volume. When using this law, the temperature stays constant. An example question and solution of this law is a balloon with a volume of 2 liters is filled with a gas at 3 atmospheres. If the pressure is reduced to 0.5 atmospheres without a change in temperature, what would be the volume of the balloon? To solve this, we would multiply 2 liters and 3 atmospheres and also multiply 0.5 atmospheres and volume 2. To solve for volume 2, divide 0.5 atmospheres on both sides so that it will cancel out, leaving behind 12 liters.
The next law we will discuss is Charles' law. Charles' law deals with the volume and the temperature of a gas. The equation for Charles' law is volume 1 over temperature 2 is equal to volume 2 over temperature 2, where V is the volume and T is the temperature. When dealing with Charles' law, the pressure remains constant within this equation. The temperature always has to be in Kelvin and never Celsius. The relationship between the two is directly proportional, which means as one goes up, the other goes up as well. An example problem for this law is 600 milliliter sample of nitrogen gas is heated from 300 Kelvin to 350 Kelvin. 600 milliliter is the volume 1, 300 Kelvin is the temperature 1, and 350 Kelvin is the temperature 2. To solve this, we will then cross-multiply 350 Kelvin times 600 milliliter and also multiply 300 Kelvin times volume 2. Next, we will divide 300 Kelvin on both sides so that it cancels out, and then we will be left over with 700 milliliter.
The final law we will discuss in this video is the Gay-Lussac's law. This law deals with the relationship between the pressure and the temperature of a gas. They have a direct relationship just like the Charles law. The equation for this law looks like pressure 1 over temperature 1 equal to pressure 2 over temperature 2. In this law, the volume remains constant. An example of a Gay-Lussac's problem is a solid cylinder contains 6 atm of gas heated at 300 Kelvin. What would the pressure of the gas be if the gas was heated to 350 Kelvin? 6 atmospheres is the volume 1. 300 Kelvin is the temperature 1. And 350 Kelvin is the temperature 2. We are looking for the pressure 2, and because the temperature went up, we would expect the pressure to go up as well. To figure out pressure 2, we will cross-multiply 6 atmospheres and 350 Kelvin, and also multiply 300 Kelvin times pressure 2. Next, we will divide 300 Kelvin on both sides so that it crosses out. The product pressure should increase to 7 atmospheres. So I'll leave you with this. If a king farts, is it a noble gas?